Good morning. Today we are going to talk about optimization. Optimization is related to determining the optimum values and the extreme values. Economics is essentially a science of study, which means that we would like to make a study about the choice of the optimum level of production. So if you study the production function, you have to determine a specified level of production that can help to maximize profit or minimize cost. This can be accomplished by a number of ways. And one of these alternatives is more desirable than another. And it is the essence of the optimization problem to choose on the basis of that specified criteria. So we would like to find the best alternative. The most common alternative is to set a goal of maximum something. Say in case of production, so we would like to maximize profit. While in case of consumption, we would like to maximize satisfaction. So we would like to maximize something, anything, okay? Or minimize cost. So the most common way in order to identify or to make any choice is to maximize something or minimize another. So optimization means the quest for the best. So from mathematical point of view, the point of maximum or minimum something is a point of extreme value. So we would like to find an extreme value. The first step in formulating an optimization problem, the first order of business is to define an objective function. So the first step of any optimization is to find objective. Objective function has a dependent variable which represent the object that we would like to maximize or minimize, the object that we would like to choose. So this function describes the choice variables, which are the independent variables. So mainly, the optimization process helps to set or to find the set of values of the choice variable that will lead to the desired maximum or minimum or extreme value of something. So once again, we would like to find set of values. Set of values of what? Of a choice variables that lead to desired extreme of the objective function. For example, we would like to maximize profit. So the objective, maximum profit. Or in other words, we would like to maximize the difference between revenues and costs, as profit is calculated as revenue minus cost. Revenue is a function of quantity, so it is written as y multiplied, y between two brackets q means function of q, and revenue is a function of quantity, and finally cost is a function of quantity. So the objective function is also the object we would like to maximize, or the objective function, or the point under consideration is maximum profit. And the choice variables or independent variables is quantity Q. So we would like to define the optimal level of Q that help to achieve the desired objective, which is maximum profit. So this is the main idea of optimization. As we said that the objective function, say for example y, will be a function of x, which are the independent variables. So objective function can be written as y is a function of x. So this is the general form. There is no restrictions as whether it is linear or non-linear, monotonic, or contains both increasing and decreasing parts. So there isn't any restrictions about this. If if the objective function is a constant function, all values of the choice variables will result in the same value of y. So there is no significant choice to be made regarding the value of x. So if y is a constant, say for example 5, so for any value of x, y would be 5. So there isn't any choice is going to be made regarding optimization, whether whether maximization or minimization of y. So this can be illustrated graphical as you can see from this figure, that y is constant. So in this case, we couldn't, there isn't any value of x that can minimize or maximize y. So this is a case of absolute minimum or a maximum range function. Another example. If x has an increasing function, just like this, so this is also an absolute minimum range. Another one. In case number 3, we can find that there are two relative points, extreme points, point E and point F, as one of them is a minimum value and the other one is a maximum one. So from this figure, we can notice that before the maximum point, the curve is increasing, so the relationship is positive relationship, while after this point, the curve is going to decrease, so it will be a negative relationship. And the opposite will be the case in case of the minimum point. In case of minimum point, first it starts with decreasing, and after the reaching the minimum point, it's gonna increase. We have to determine whether the point is a maximum point or a minimum point. So first of all, or the first step in order to identify maximum or minimum, or to reach our objective maximum or minimum, is to find the first derivative. So first derivative test is the first step. The first derivative test identify the inflection point, the turning point. So this shows inflection point. It doesn't identify whether it is a maximum point or a minimum point. It's just a reflection. Um, After this point, there is an inversion. It's going to be the inverse relation is going to occur. Okay. So let's take an example in order to do the first derivative test. Say for example y equals x to the power 3 minus 12x squared plus 36x plus 18. So based on the first derivative test, we have to find the first derivative with respect to x, or f dash x. This means the first derivative of y, or dy by dx. So it will be 3x squared minus 24x plus 36. So in order to find the quantities that's going to maximize or minimize, point of maximization or minimization, we are going to equate f of x with 0. So it's going to be 3x squared minus 24x plus 36 equals 0. Then we are going to use factorization or the quadratic formula in order to find the possible solutions for x. So the possible solutions for x, it will be x equals 6 or x equal 2. This means that there are two turning points in this case, or inflection points. It's something like just like this. So this means that there is an inflection point or turning point, but this condition doesn't determine whether it is a maximum point or a minimum one. So another example, if you know that this is the average cost function, which is a function of quantity, it is q squared minus 5q plus 8, and the required is to find the point of extreme something, extreme minimum or maximum, whatever. In case of cost, is gonna be extreme minimum. Of course, we would like to minimize cost. So it is function of first derivative with respect to q is gonna be 2q minus 5. This is gonna be equated by 0 in order to determine the quantity at which there is an extreme value. So it is 2q minus 5 equals 0. Q will be 2.5. In order to identify whether this point is a maximum point or a minimum point, we have to find the second and the higher order derivative. So the second test that we are going to perform in order to make sure that this is a minimum or a maximum point, is second derivative test. So the first derivative helps to find the rate of change, while the second one helps to find or identify whether it is a maximum or a minimum point. If the value of the second derivative is greater than 0, so this is a minimum point. If it is less than 0, so this is a maximum point. As illustrated before, before this point, the value is increasing, so it is a positive value. After this point, the value is decreasing. So if it is negative, this means that the value is going to decrease, and this is the maximum point. In this case, the value is decreasing before reaching the minimum point, and after this point, the value is going to increase. So it is a positive 1. So if it is positive, this means that the point is minimum point. So if the value is greater than 0, which means it's positive, so this is minimum 1. If it is less than 0, it is negative, so it is a maximum point. Actually, we can find in economics many turning points, whether increasing or decreasing. Say, for example, in a production function, we are going to make a little bit review about the shapes of different curves in economics. So in case of production function, as we said before, that production passes through 3 different stages. But we can reach the maximum point of production, or the maximum output that can be produced in order to be able to maximize profit. The same with respect to costs. This is minimum marginal cost. This is minimum average variable cost. This is minimum average total cost. Okay, so all of this can be a minimum points that can be found using optimization. Also with respect to marginal productivity or average productivity of labor. So this is the maximum of the marginal productivity of labor, and this is the maximum of average productivity of labor. All of these points are optimization points. The same with respect to total revenue. This is total revenue and this is total cost. We would like to find the maximum profit, which is the highest difference between both of them. Okay, so this is some of the turning points that we can find in economics. Okay, returning back to our second condition. Let's take an example. Assume that y equals 4x squared minus x, and we would like to find an extreme value and identify whether it is a maximum point or a minimum one. So the first step is to find the first derivative and equate it with 0. The first derivative would be 8x minus 1. Then we are going to equate it with 0. 8x minus 1 equals 0. So the value of x will be 1 over 8. But we do not identify whether this is a maximum point or a minimum one. So we have to find the second derivative. So it will be 8, which is a positive value, which means that this is minimum value. So what this means that at the value 1 over 8, this is the minimum value of it. Another example. If you know that y equals x to the power 3 minus 3x squared plus 2, the first step is to find the first derivative with respect to x. It will be 3x squared minus 6x equated with 0. So x will be 0 or 2. So we have to find the second derivative. It will be 6x minus 6. So we have to substitute using the two values of x instead of it in order to find whether it is a maximum or a minimum point. So if second derivative of x, 6 multiplied by 0 minus x, so the value is negative x. So it is negative value. So this is the maximum point, and we are going to find 6 multiplied by 2 minus x, which is 6, is a positive value. So this is a minimum point. So the value of x equals 0 is a minimum 1, is a maximum 1, and the value of x equal 2, this is the minimum point. Okay, if you are given a revenue and cost functions, and we would like to maximize profit. So say for example this is revenue, $1,200 minus 2q minus 2q squared, and cost function is q to the power 3 minus 61.25 q squared plus so the profit function will be the difference between revenue minus cost. So it is negative q to the power 3 plus, we are going to subtract negative 61.25 from negative 2q. So the value will be 95.52 q squared. And then with respect to q and q, we are going to add the subtract 1500 from 1200. So the value will be negative 3 to 8.5 q, and finally negative 2000. So we would like to find the extreme values or the critical values. So we are going to get the first derivative with respect to q. It's negative 3q squared plus 118.5 q minus 328.5 q. And then we are going to equate it with 0. We can use the formula, so we can find that the value of q can be 3 or 36.5. Then we have to find the second derivative. It will be negative 6q plus 118.5. We are going to substitute using the values of q to identify which one of them is a maximum point and which one is a minimum one. After substitution, we can find that when q equals 36.5, this is the maximum point. Okay. As the value is going to be negative in this case. This is the end of our lecture today. Thank you.